Fluid flows into a storage tank at a rate given by F-T as 100 e to the 0.2 t. T is measured in hours. Initially, there were 700 litres of fluid in the storage tank. So we have F' of t is 100 e to the 0.2 t. So F of t, and don't forget this is a calculator paper, you could integrate this on your calculator, is 100 e to the 0.2 t divided by 0.2 plus a constant. So that's going to be 500 e to the 0.2 t plus a constant. Now we know that f of 0 is equal to 700, so that's going to be equal to 500 plus c if t is 0. E to the 0.2 times 0 is just 1, and therefore c is equal to 200. So we now have that f of t is 500 e to the 0.2 t plus 200. What we now need is f of 3. So that's just a calculator job. So we've got 500 multiplied by e to the 0.2 times 3, so that's 0.6, and then we need to add 200. So let's go back to decimal. So that gives me 1111.05 and so on. Now that's how much is in the tank at the end of 3 hours. So we need to do that number, take away what was originally in the tank, which was 700. So we'll just do last answer, take away 700. That's 411. Will we ask for any particular degree of accuracy? No, we won't. So I'm going to give that as 411.06 litres. And I'll state that I've given that to 2 decimal places. Determine the time taken for the amount of fluid in the storage tank to reach 10,000 litres. So we know that the volume at time t was given by this expression, and we just want to put that equal to 10,000. And of course it's a calculator paper, so we can solve on our CAS. So I'm going to clear a bit of space. So action, advanced, solve, and then I'm going to put 500 e to the 0.2 x plus 200. Be careful that you come out of the power when you do this, is equal to 10,000, and execute, and that gives me 14.877. So I'm going to say approximately 15 hours.